What's up, Algebra 2? Here we are with partial roots. So yesterday we did nth roots, and we were reducing radicals, cube roots, fourth roots, fifth roots, and everything worked out perfect. Today we have partial roots, which means not everything's going to work out perfect. Okay? So, example there from yesterday was 16x to the fourth. The square root of 16 is 4, and then x to the fourth, you do power divided by the root. Okay, so fourth power divided by the second root, or square root, we'll have 4 over 2 for x squared. But what if these things don't come out perfect? Okay, like 32, x to the fifth. 32 is not a perfect square, and 5 does not divide by 2 perfectly. We're going to split these up into the biggest perfect piece that works with whatever radical we're doing, and then have some leftovers. Okay, so I've split 32 into 16 times 2, and x to the fifth into x to the fourth and x to the first. So I can do the square root of 16. That's going to be 4. And I can do the square root of x to the fourth, that's x squared. Now I do have some leftovers that would still be under a radical. 2x to the first, or just 2x. So that's what we're doing today, breaking it down, reducing it, simplifying it into pieces that we can do, and then having some leftovers probably still under the radical. So 75, we're going to split that up into 25 times 3. Okay, x to the seventh, we're going to split that up into x to the sixth times x to the first. Okay, 7 does not divide nicely with 2. So we're going to go x to the sixth and x to the first. 3 also does not divide nicely by 2. Remember, if there's no number on your root, it's going to be a square root or a second root or a 2 out there. And then we'll go y to the second, y to the first. Okay, we have a handful of these that we can do. They are perfect. So like 25, that's going to be 5 on the outside. Leave that one for the inside. X to the sixth, 6 divided by 2 is x to the third on the outside. Y squared, square root, is going to be y to the first on the outside. Our leftovers that are staying inside the radical are 3, x to the first, y to the first. Okay? On our next one, we do have a group to the fifth power, so just pretend like that's one variable. Let's have you go ahead and push pause and try that one on your own. Alright, let's see how we did. 28. I want to break that apart into 4 times 7. And then this group to the fifth power, 5 does not divide nicely with 2. I'm going to break that up into to the fourth power times that same group to the first power. Alright, square root of 4 is a 2 on the outside. This group to the fourth power square root will have that group squared. Okay, and then our leftovers that were not perfect squares, we have 7. And then that grouping to the first power. Okay, now we're going to have to shift gears, change your mindset here a little bit. We're going to be doing this with cubes. Cubes. Okay, so what's our first perfect cube that would fit into 24? Okay, we're going to think about 2 to the third. That's 8. So these are all cubes. So I want 8 times 3. And now I want my exponents to divide by 3. So I'm going to change the 7 to x to the sixth and x to the first. 8 does not divide nicely by 3, so I'm going to break that down to y to the sixth and y to the second. Alright, so we have some nice cubes that we can do, and then we're going to have some leftovers that stay inside. The cube root of 8 is going to take me down to 2. X to the 6th power divided by root. 6 divided by 3, we'll have x squared on the outside, and we'll have y squared on the outside. Left over, cube root 3, x to the 1st, y to the 2nd. Okay, let's have you try another one on your own. Go ahead and push pause, and let's try this one again. And your hint for this one is that 5 cubed is 125. All right, go ahead and push pause and give this one a shot. All right, so 5 cubed is 125. So that's going to help me because I can split 250 up into 125 times 2. Z to the 13. 13 does not divide nicely by 3. So we're going to go Z12 and Z1. And then, hey, this parentheses to the 9th. 9 does divide nicely by 3, so we're just going to leave it alone. Okay? And this was a cube root, not a square root. So make sure you put that 3 there, Mr. Handke, so we don't forget what we're doing. Okay, we got a 125 cube root. It's going to drop it down to 5. That'll drop down to z to the 4th. And we'll have this group to the 3rd. Inside our cube root, our leftovers, we're going to have that 2 and that z to the 1st. If you don't want to put the first, like the 1 exponent on these, you don't have to. Let's do one of these bigger ones, and then we'll call it a day on the front side. We do have some complicated ones to look at on the back. Let's do over here. So if you're doing a 4th root or a 5th root, okay, the bigger the root number, the more likely it is that these are going to be something with a 2 or a 3. Okay, so 3 to the 4th is 81, and that's going to work out nicely with our 162. So we'll have 81 times 2. Okay, 5 does not work perfectly with 4, so we're going to split that up into x to the 4th, x to the 1st, and our y to the 15th, we're going to go y12, y3. All right. 4th root of 81 is a nice 3 on the outside. 4th root of x to the 4th is going to be x to the 1st on the outside and y to the 3rd on the outside. Inside, we're going to have 2x y to the 3rd. Okay, if you want to have some extra practice there, you can. We're going to flip it over to the back and look at some of these. So this one's a little bit different because now we have a fraction. We've got a top and a bottom. And if you remember from reducing your radicals in geometry and earlier this year in Algebra 2, we don't want to have a radical in the denominator. Okay, so on the front side of this note sheet, we are breaking things apart and simplifying. For the back side, we're actually going to be building things up a little bit so that it does work out nice. Okay, remember with a fraction, square root of a fraction, we can separate it to square root of the top, square root of the bottom. Okay, this bottom one's not going to work out perfect. We could reduce this bottom one like we did on the front and split this up into y to the 6th and y to the 1st, but then we still have a leftover radical on the bottom. So I'm going to build it up a little bit so that it does work perfectly. What could I multiply to the top and the bottom so that it works out perfectly? I just need one more y. We're going to go y to the 1st inside those radicals, top and bottom. And now we're going to have the square root of x to the 6th, y to the 1st on the top, and the square root of y to the 8th on the bottom. So now the bottom's going to work out perfect. Is y to the fourth. On the top, we can do the x one. We'll have x to the third on the outside, and then we'll still have a leftover on the inside of y to the first. Okay? So we can do that because you can multiply the same thing to the top and the bottom, because y to the first over y to the first is 1. It didn't change the value. And we wanted to do that so we could have a nice answer on the denominator, and the top it's okay to have leftovers. Alright. Same idea over here. We're getting kind of tight on time. If you want to try that one really quick, go ahead and push pause. I'll put the answers up there. Okay, with that one, we need one more y on the bottom, so we go y1, top and bottom. Now we have y to the sixth. Square root of y to the sixth, we're going to have y to the third. Okay, on the top, we're not going to be able to do much with that y to the first, and our x to the ninth isn't perfect either. Now the top, it's okay to have a radical, so we're not trying to fix it. We'll just break it down to 8 and 1. Square root of x to the 8th, it's going to be x to the fourth on the outside, and we'll have that leftover x to the first, y to the first on the inside. Okay, let's drop down to the bottom. Now when you have a bunch of stuff, like this was x on top, y on bottom. When you have a bunch of stuff on the top and the bottom, I'm going to suggest we simplify first. Sometimes it works out well, sometimes it doesn't. It ends up being a wash and not really helping out much. Okay, so if we're going to reduce 2/16, that'll reduce to 1 over 8. Okay, x squared over x to the third. X squared over x to the third. When we're dividing like this, we can subtract exponents. So 3 minus 2 is going to be x to the first. And we put it where the biggest one was. It was on the bottom, so we'll have x to the first on the bottom. And then 4 minus 1, we'll have y to the third on the bottom. Okay, so like I said, now we're trying to build this denominator back up so that it works perfect. I'm not interested in like breaking these down and simplifying and then still having leftovers. So 8, what's the first perfect square that I could make it be? Times 2 for 16. So we're going to do times 2, top and bottom. That's going to make that be a 16. Then I'm also going to go, I need one more x. So we're going to do x to the first, top and bottom. And I also need, we're building up, all right? We're filling it up. I need one more y to make that be y to the fourth so that that one works out nice. So we have 2xy on the top, and on the bottom, we should have a bunch of stuff that's perfect. 16 x squared y to the fourth. And I can do that, so we'll have 4x y squared, and then on the top, we'll just have our radical. Okay? Tough stuff. This is tough stuff. And this one, it wasn't really worthwhile to reduce it. I think overall, the reduce it first strategy does help. But that one, we ended up basically undoing all of our reducing with fixing it. Let's do one more quick. Now this is cube roots, so think about that. Cube roots. Okay, so step one, we're going to reduce. So we're going to have 1/4. We'll have x to the fourth on the top. 7 minus 3, we'll have x to the fourth on the top. 4 minus 2, we'll have y squared on the bottom. Okay, we need these to be cubes. Cubes. Third power. Okay, so I need this to be back to an 8. So we're going to do times 2. So we kind of undid that one. And then I need y to the third. I need one more y. So on the top, I've got 2 x to the fourth, y to the first. And on the bottom, I should have some perfect cubes. 8y to the third. Okay, cube root of 8 should be a nice 2 on the bottom. Cube root of y to the third should be a nice y on the bottom. On the top, it's okay to have a radical left over on the top. So that 2 and the y, nothing I can do there. This x to the fourth, I can break that down a little bit. If you want to do a whole other line of work, you can. I'm going to do a little scratch work right here and change that to a 3 and a 1. So the cube root of x to the third will be a nice x on the outside. And then inside, our leftovers, we have 2, x to the first, y to the first. Okay? And I'm going to run out of time for this one. The bell's about to ring here, so I'm going to run out of time for that one. That should be a good start there for you guys. This backside is definitely tough stuff. That's pretty deep conceptually. I don't think the front side is much further of a leap than what we had yesterday. So I think this is going to be pretty good for most of us. And the backside does get a little deep here. Okay, we're getting into the deep end of the pool. But you can do it. Give it a shot. Try your best. And let's see what happens. All right, thanks for watching and good luck.